Alright, so now basically we've covered part of Black Hole, the Ford theory and everything, what happens from the beginning up to the point of where it becomes the elder star, the grandfather star, going through its process of losing its material buoyancy and density. More or less what I ended with last time is what happens where I believe a black hole in a star, when a star finally loses its diamagnetic properties to repel itself from the magnetic field of a black hole, is when it gets sucked into it, and that's why we have things that are called supernovas. And basically what it is it's causing a diamagnetic force and a giant gaseous ball to get sucked into a field that it doesn't want to be in. And I actually have theorized that the sun has a lot of, I guess you could say, electromagnetic properties because it has a lot of precious metals. I believe that the black holes are basically a lot of things like cobalt, iron. I mean, I know it's weird, but if you know anything about space, a lot of these things everything comes from stars. We did. Like, we're meteorites. If you have gold on your ring, that literally came from a supernova. So, yeah. It's well known. But, basically, what we have here now is the black hole is the end stage. And you have the middle stage, which is the actual star in and of itself. Well, technically, there's like a 2.5 stage where it goes to 3 after. What 2.5 is basically when the material separates into buoyancies from beyond the star, because it then breaks down again, ultimately. So it goes from the first stage, where it's waves of gaseous matter, where it's concentrated into its own reservoir through different manipulation of basically material sciences, different physics. I don't want to get into all of it because I don't have all the time in this video, but basically what it's doing is just reorganizing. So heat wants to stay away from cold, so the heat of the sun stays away from, let's say, what we call the void. What I call that is basically just an inert gas, something like helium, but not quite. But I believe that's where a lot of the cold gases in the solar system like to hang out, because they don't have to deal with fusion trying to ignite them or anything messing with them. They get to sit there dormant, and it becomes where they sit. Then you have the dark matter, which sits on the opposite side, because dark matter and light matter, well, I think dark matter likes the light matter, but it's light matter doesn't like it so much. I don't know. I know it's kind of a weird thing, but when you're talking about stars and how they operate, it's kind of getting into magnetic properties and to actually explain Lorentz force and a lot of that stuff just gets really in depth. So I'll get to it.